Hello everyone, my name is Anissa and today I would like to present on Cheminformatics. Before we go details, we should know what is Cheminformatics. So, it is defined as the field of solving chemical problems with computer. Cheminformatics can be divided into three areas, which is capturing data using lab notebooks, second one, storing data, and the third one is mining data. So, what are the aim of Cheminformatics? The aim for Cheminformatics is to support better chemical decision making by storing and integrating data in maintainable ways, providing open standards and tools allowing application and data use across heterogeneous platforms and mining the many chemical property spaces in a time and space efficient way. Going to the next slide. So, common terms that are used in Cheminformatics are: first one is CML, which stands for Chemical Markup Language. It is capable of supporting a wide range of chemical concepts such as molecules, reactions, computational chemistry, spectra, and analytical data. It also can manage the molecular information using tools such as Java and XML. Second term is SMILES. SMILES stands for Simplified Molecular Input Line Entry System. It can represent as molecular structure and chemical reactions. SMILES is more simpler and compact compared to INCAI notation. So, the third one is INCAI. INCAI stands for International Chemical Identifier. It is widely used but still limited. It provides a precise and strong IUPAC approved structure derived tag for a chemical substance or structure. For example, it cannot differentiate between certain types of stereoisomers and is sensitive to tautomeric chemical forms. Bridging Cheminformatics and computer science. As example, Cheminformatics methods risk minimization in drug discovery, which means it minimizes the chances of a small molecule failing due to poor physical, chemical, or biological properties during research and development as a drug candidate. For example, a molecule must be soluble and show a certain degree of bioavailability to be considered a drug candidate. In cases where these properties are poor, a Cheminformatics approach can suggest replacement of certain functional groups to maintain potency but improve the solubility and bioavailability. We move to the next slide. Why Cheminformatics is important? First, because it representing and searching structures such as ChemBLDB and PubChem. Second one, study the molecule in their biological context. Third one, mining activity and prediction such as creating drugs for COVID-19. Then, expanding chemical space that leads to danger. And the last one is knowledge management. So, next, some challenges that are faced by nearly all Cheminformatics. First, the chemical representation of a molecular will need to capture non-static graph to account for the localization and tautomeric. Second, big size data and required a longer time. Then, understanding their underlying chemical systems. And the last one, data is not being indexed properly. Finally, we have come to the conclusion. So, based on what I have learned from the article about Cheminformatics and also what can I see in our world, in our real life right now, is Cheminformatics is very important. Discovering drugs to a disease is still a challenging task for medical researchers due to the complex structures of biomolecules which are responsible for diseases such as AIDS, cancer, autism, Alzheimer, etc. Design and development of new, efficient, and drugs for the disease without any side effects are becoming mandatory in the recent history of human life cycle due to changes in various factors which includes food, habit, environmental and migration in human lifestyle. Cheminformatics deals with discovering drugs based in modern drug discovery techniques which in turn rectifies complex issues in traditional drug discovery system. Cheminformatics tool helps medical chemists for better understanding of complex structures of chemical compounds. So that's all from me. Thank you.